Welcome to this explainer. Today, we're diving into the high-stakes mechanical detective work that comes into play when your refrigerated trailer starts losing the battle against extreme summer temperatures. Look, if you're hauling temperature-sensitive freight, you already know that keeping that box cold isn't just about comfort, right? It's literally the entire job. So today, we're going to look really closely at what happens when the heat turns up and your hardware starts to struggle. Picture this. It's the absolute nightmare scenario every driver dreads. The unit actually sounds like it's working perfectly. You hear the hum, the compressor is definitely running, but a quick glance at the display shows a major crisis unfolding. The temperature inside the trailer keeps climbing past your set point, and suddenly a massive load of frozen goods or fresh produce is on the line. It's incredibly frustrating, right? Because the system is clearly working hard, but it's actively losing the fight. And if we don't catch and diagnose this correctly, well, that could easily cost thousands of dollars in spoiled cargo. Okay, here's our structured roadmap for today. We'll be covering the cooling crisis, how to read the symptoms, the 4 common culprits, the extreme heat factor, your immediate action steps, and finally, how to save the load. Let's jump right in. Section 1. The cooling crisis. This is what happens when the unit is working incredibly hard, but completely losing the fight. And in this situation, the clock starts ticking immediately. Okay, so to really figure out what's going wrong here, we have to start with a fundamental truth about how these machines actually operate. Transport refrigeration systems are closed-loop systems. All that means is they are completely sealed, and they circulate refrigerant to pull heat out of the trailer. Now, you might be wondering, why does this matter? Well, because a closed-loop system doesn't just consume refrigerant the way your truck's engine burns through diesel fuel. So if your system is low on cooling power, because it lacks refrigerant, it didn't just use it all up. Actually, scratch that, it couldn't have used it all up. It means you've got an underlying mechanical leak or a failure. You can't just top it off and ignore it, you really have to find the breach. Moving right along to Section 2, reading the symptoms and determining the true nature of the failure. Correctly spotting these symptoms is basically your vital diagnostic fork in the road. This setup brilliantly illustrates the 2 main types of failures we see, and it really helps you figure out if your system lacks physical capacity or if its electronic brain is just making terrible decisions. First, if a unit is running nonstop and still can't hit the target temperature, your system simply lacks the physical capacity to do the job. That strongly points to a physical problem, like refrigerant loss, a blocked condenser, or maybe a failing compressor. Now, contrast that with a unit that cycles off early. It completely stops running before it reaches the set point, letting the temperature drift up before kicking back on. This is almost always a control system issue. The mechanical parts, they might be totally fine, but a bad thermostat, faulty sensor data, or a confused controller is just telling the unit to stop cooling when it absolutely shouldn't. Which brings us to Section 3. 4 common culprits. The usual mechanical suspects. Now that we know how to read those high-level symptoms, let's interrogate the primary causes behind your lost cooling capacity. So what's really fascinating here is how these 4 main culprits have completely distinct behaviors. First up, refrigerant loss. Because it's a closed loop, a leak basically causes a slow starvation of heat removal over a few days. Next is a dirty condenser. Think about it. Packed with road dust, debris, and bugs, it physically blocks the airflow the unit desperately needs to dump that heat outside. Third, we have compressor problems. If you've got worn seals or low oil, the system loses its driving pressure. You might literally hear it running incredibly loud, but it just can't keep up. And finally, electrical faults. These are the tricky ones. A thermostat rating just 4 degrees off or a sensor that drifted out of calibration can cause the controller to make terrible decisions. You get a warm trailer without a single broken pipe or belt in sight. Section 4. The extreme heat factor. Here is how those brutal Dallas summers completely compound the danger, ruthlessly exposing any hidden mechanical weaknesses. I want you to really focus on this number for a second. 70. A 70-degree temperature differential is the massive hurdle a reefer has to fight when it's trying to maintain a 34 degrees set point inside that trailer, while it is a blistering 104 degrees outside. That is just an enormous amount of thermal energy to constantly push back against. To put that into perspective, let's see how this builds into a total crisis. Imagine you've got pleasant spring conditions, say 72 degrees outside. Your unit only has to overcome a 38-degree differential to hold its 34-degree set point. Easy enough, right? But in peak summer conditions at 104 degrees, that differential jumps to 70. The unit is suddenly being forced to move nearly twice the amount of heat to do the exact same job. So severe heat doesn't necessarily create new problems, it just exposes them. A condenser that was 70% efficient and slightly clogged in March, by August, it's completely overloaded. A tiny refrigerant leak that was manageable in April suddenly becomes a critical, catastrophic shortage by July. So what on earth do you do? Section 5. Immediate action steps. Here is the triage protocol for a failing unit when the clock is ticking and your load is literally melting. All right, here are your 3 non-negotiable rules right on the side of the road. Step 1, keep the trailer doors closed. I know it sounds incredibly basic, but it is absolutely vital. Every single time those doors open, a flood of hot ambient air rushes in, making that struggling unit work even harder. Keeping the doors sealed buys you precious time. Step 2, check the controller display for alarm codes and write them down immediately. And step 3, stop resetting the unit repeatedly. This is a trap so many drivers fall into, just hoping the unit will magically fix itself. Let's talk about that last point for a second, because understanding why those repeated resets are so dangerous is crucial. Look, one reset, totally reasonable if you think the alarm might just be a momentary sensor glitch. But if that alarm comes back, you have to stop. Repeatedly hitting reset clears vital alarm codes from the display. It quite literally hides the active problem and erases the very clues the mobile technician is going to need to rescue you. Plus, it absolutely does not fix the underlying mechanical issue. All it does is force an actively struggling, starving system to keep running, which rapidly accelerates expensive damage. You are essentially turning a simple leak into a blown compressor. Finally, Section 6, saving the load. Let's look at real-world solutions and how professional on-site rescue makes all the difference. Now, you might be wondering, hey, does my specific hardware change the playbook? The short answer is no, not really. Whether you're running a Thermal King or a Carrier Transicold unit, the failure categories are exactly the same. Both systems suffer from refrigerant loss, dirty condenser coils, compressor wear, and electrical faults. The only real difference is how the computer reports the problem and the specific replacement parts it needs. But practically speaking, both can be fully resolved by dispatching a tech with the right tools directly to your truck stop, your yard, or even the shoulder of the highway. Let me share a quick story that perfectly captures the stakes here. A driver named Elton Zanali was facing a failed reefer with a fully loaded trailer of ice cream in 100-degree heat. Talk about a ticking time bomb, right? But because the mobile repair team arrived with the right brand-specific parts already on their truck, Elton noted, a job that needed 7 hours to get done, he got it done in 2 hours. This real-world testimonial beautifully proves that having the correct parts on hand for a rapid on-site rescue can mean the absolute difference between saving a load of ice cream and taking a total financial loss. So, I want to leave you with this provocative final thought to chew on before you take your next load in the dead of summer. Is your reefer actually ready for the 100-degree heat, or is it just waiting to fail? Remember that 70-degree differential we talked about? The heat will absolutely find your unit's weak spots. But understanding these symptoms, knowing not to clear your alarm codes, and calling for targeted on-site maintenance are your best tools for survival. Because at the end of the day, preventative maintenance is always, always cheaper than a spoiled trailer. Thank you so much for joining us for this explainer, and hey, stay cool out there on the road.